are no solution. If you did graph these, there would be parallel lines that do not cross. If they do not cross, we cannot get a solution using elimination or substitution. Second question, and last question for the section. 2x plus y equals 3. And second equation, 6x plus 3y equals 9. Again, solving by elimination. On this one, we'd have to multiply first, since the x's do not match up and the y's do not match up. So if we multiply the first equation by 3, we can multiply by 3 so the x's would match up. 3 times 2 would be 6x. 3 times y would be 3y. And 3 times 3 would be 9. When we multiply the first equation by 3 and compare it to the second equation, both equations are exactly the same. If you continue the elimination process, subtracting, the x's would cancel, the y's would cancel, and the 9's would cancel. So we'd be left with 0 equals 0. Similar to the other question, if all the variables cancel out, but you're left with a true statement, 0 is equal to 0, the answer would be infinite solutions. Infinite solutions means there's many points or many solutions for these equations. In terms of a graph, this would be a line on top of that same line. If you take any point on the line, it also works for the other line. Title of the first section today is Graphing. Systems of inequalities. First inequality is y is greater than or equal to negative 4x minus 3. Second inequality, y is less than negative 4x plus 1. To graph these inequalities, they're both in mx plus b form, so we can use the slope-intercept form to graph. The first inequality, m is equal to negative 4, the number in front of x, and b is equal to the last number, negative 3. Second inequality, m, is also equal to negative 4, and b, the y-intercept, is equal to positive 1. Graphing these two inequalities on a xy axis. The first inequality, the y-intercept, is at negative 3. And the slope is negative 4 or negative 4 over 1. So we'll go down 4 spots and to the right 1 spot. The first inequality is greater than or equal to, so this line would be a solid line. For shading this graph, y is greater than negative 4x minus 3. If y is greater than, we'll shade everything above the line. In this case, it will be to the right side of the line. The second inequality, starting at positive 1 for the y-intercept. Slope is also negative 4 or negative 4 over 1. So we'll go down 4 spots and to the right 1 spot. This inequality is less than, so it will be a dashed line. And the inequality is y is less than negative 4x plus 1. Less than means we'll have these smaller y values, or everything underneath this line, or everything to the left of the line. Since we want everything bigger than the first line and smaller than the second line, the common area is everything that's in between the two lines. And that would be the graph for the inequalities. Title of the last section today is More Graphing Systems of Inequalities. First inequality, x is greater than or equal to 2. And second inequality, y is greater than 3. To graph these two inequalities, we can draw the xy axis. For the first inequality, x is greater than or equal to 2. If we put a point where x is equal to 2, and the equation x equals 2 would be a vertical line passing through 2. The inequality is x is greater than or equal to negative, x is greater than or equal to 2, so we want the numbers bigger than 2, which would be to the right of this line. Second inequality, y is greater than 3. Again, we'll go on the y-axis up to positive 3. And if it was an equation y equals 3, it'd be a horizontal line going across. Since it's greater than 3, it'll be a dashed line going through 3. And y is greater than 3, we want the numbers bigger than 3, which would be above this line. The part that would be shaded in common would be the top right hand corner, would be the common shaded part for the graphs. Second inequalities and last inequalities for the section. 12y plus x less than or equal to 32. And x minus y less than or equal to 6. These equations are in standard form, where we have x and y on the same side. To graph these, we can use intercepts. The first equation, 12y plus x less than or equal to 32. If we plug a 0 in for x, we'll have 12y plus 0 less than or equal to 32. The 0 we can cross off or ignore, so we'll have 12y is less than 32, and dividing by 12, we'll have y is less than or equal to. Reducing fractions, we can divide by 4, and we'll have 8 over 3. Doing the same equation, but this time we'll put a 0 in for the y. 12 times 0 plus x less than or equal to 32. 12 times 0 we can ignore, and we'll have the second intercept, x is less than or equal to 32. So the two intercepts for the first inequality, y is 8/3 and x is 32. If we do the second equation, plugging in zeros, if we do a 0 for x, we'll have negative y is less than 6. Dividing by a negative 1, we'll have y. And dividing by a negative 1 would change the inequality to less than or equal to negative 6. And again, solving the second inequality for the x-intercept. We can plug a 0 for y. X minus 0 is less than or equal to 6, or x is less than or equal to 6. Graphing this equation. The first inequality, the y-intercept was 8 over 3. 8 over 3 is the same as 2 and 2/3, so a little bit less than 3. And x is less than or equal to 32. We go out to x is 32, the intercept would be at 32. This inequality was originally less than or equal to, so it will be a solid line. We'll graph the second line and then we'll shade afterwards. The second inequality, the y-intercept was at -6. And the x-intercept was at +6. Again, this inequality was less than or equal to, so it would be a solid line. Last part will be shading. If you look back at the first inequality, 12y plus x less than or equal to 32, we can use a test point for 0, 0. First inequality would be 12 times 0 plus 0 less than or equal to 32. 12 times 0 would be 0, plus 0 would be 0, and we have 0 is less than or equal to 32. This is a true inequality. So the first line that we graphed was this top line. 0, 0 would be the part that's shaded, so this line will shade underneath or to the bottom of the line. Second inequality, x minus y less than or equal to 6. Again, plug in zeros for x and y. 0 minus 0 would be 0, and we have 0 is less than 6, which again is a true inequality. So the second line that we graphed will shade the side with 0, 0, which would be above this line. The side that's in common, below the first line and above the second line, will be the section on the left-hand side. And that would be the graph for the section. Title of the first section today is Solving Systems. In 3 variables. The section will have equations that have 3 variables, and we'll solve for all 3. First equation is x plus 2y plus z equals 10. And second equation, 2x minus y plus 3z equals -5. And last equation, 2y equals 8. So 3 equations, 3 variables. We'll figure out what x is, what y is, and what z is. Looking at the equations, the third equation we can solve by dividing by 2. And our first answer, y would equal 4. Once we know one variable, we can plug it back into each of the other equations. So the first equation would be x plus 2y, or 2 times 4, plus z equals 10. Solving this one, we'll have x plus 8 plus z equals 10. And subtracting 8 on both sides, we'll have x plus z equals 2. Looking at the second equation, if we rewrite that one, we'll have 2x minus y, but y is equal to 4. So 2x minus 4 plus 3z equals negative 5. Simplifying, add 4 to both sides, and we'll have 2x plus 3z equals negative 1. After solving for y and plugging it back into the first two equations, we have x plus z equals 2 and 2x plus 3z equals negative 1. If we take this first equation and multiply by 2, the 2x will match up with the other 2x, and we'll be able to eliminate them using elimination. So taking the equation x plus z equals 2, we'll multiply by 2, which will be 2x plus 2z equals 4. And again, using elimination, we can subtract these two equations. So 2x minus 2x would cancel. 3z minus 2z would be 1z, or just z. And negative 1 minus 4 would be negative 5. So our second answer, z equals negative 5. So we have y equals 4 from the original problem, z equals negative 5. Once you have two variables, you can plug it back into either the first equations to solve for x. If we take the first equation, which was x plus 2y, but instead of y we'll put in 4, and plus z, but instead of z we'll use a negative 5, and equals 10. Solving from here, x plus 8 minus 5 equals 10, or 8 minus 5 would be x plus 3 equals 10, and subtracting 3 on both sides, we'll get our final answer, x equals 7. So we have three answers. All three answers you can write as a single point, which will be x, which is 7, y, which is 4, and z, which is negative 5. So our final answer would be 7, 4, and negative 5. Title of the last section today is More 3 Variable Equations. First equation is 2x plus y plus z equals 14. And negative x minus 3y plus 2z equals negative 2. And last equation, 4x minus 6y plus 3z equals negative 5. To solve these equations, you want to first eliminate one variable. For example, if we take the second equation, which has negative x, we can multiply that by 4, so we can eliminate the x's. Multiplying by 4, we'll have negative 4x. And multiplying each number in each term by 4, we'll have negative 12y plus 8z equals negative 8. Combining this equation with the third equation, we can add those together to cancel out the x's. Negative 6 plus negative 12y would be negative 18y. 3z plus 8z would be 11z. And negative 5 plus a negative 8 would be negative 13. Now we have one equation that has only two variables, y and z. Now what we can do is go back and use the very first equation, which we did not use, and use either of the other two equations to eliminate that same variable, which will eliminate x. For example, if we rewrite the first equation, 2x plus y plus z equals 14. And then we can take the second equation. Instead of multiplying by 4 though, we can multiply by 2, so the x's would cancel. Multiplying by 2, it would be negative 2x. 2 times a negative 3y, negative 6y. 2 times a positive 2z would be plus 4z. And 2 times a negative 2 would be negative 4. Combining these two equations, we can add these together to cancel out the x's. Y plus a negative 6y would be negative 5y. Z plus 4z would be 5z. And 14 plus a negative 4 would be 10. And again, we have another equation with just two variables, y and z. Once we have two equations with two variables and the same two variables, y and z, we can combine these two to eliminate either the y's or the z's and simplify from there. If we take the equation that we had before with x and y, or with y and z, we can multiply negative 18 by 5. That way the y's will match up after we multiply the second equation. 5 times negative 18 would be negative 90y. 5 times 11 would be 55z. And 5 times a negative 13 would be negative 65. Multiplying the last equation we had, we can multiply this equation by 18. That way again the y's will match up. 18 times a negative 5 would be negative 90y. 18 times a positive 5 would be 90z. And 18 times 10 would be 180. These equations again, the y's have the same coefficients. We can subtract these. So negative 90 minus a negative 90 would cancel out the y's. 55 minus 90 would be negative 35z. And negative 65 minus 180 would be negative 245. After eliminating the x's and now the y's, we're left with just z. And we can divide by negative 35 to get our first answer of z equals 7. Continuing this question, once you find one variable, you can plug it back into any other equation to solve for the others. An easy equation to use would be one that has z and one other variable. For example, the last equation we had with y and z would be negative 5y plus 5z. But instead of z, we can put a 7 in, and equals 10. Solving from here, negative 5y plus 35 equals 10. Subtracting 35 on both sides, negative 5y equals negative 25. Dividing by negative 5. And we'll have our second answer, y equals positive 5. Once we have both two variables, z and y, We can plug them into any other equation to solve for x. If we take the very first equation in the original problem, which was 2x plus y, but we can substitute a 5, plus z, which would be 7, and equals 14. Solving from here, 2x plus 12 equals 14, minusing the 12 on both sides, 2x equals 2, and dividing, we'll have x equals 1. So we have three answers for the question: x equals 1, y equals 5, and z equals 7. And again, you can write this as a point x comma y comma z, which would be 1 comma 5 comma 7. Title of the first section today is 3 variable equations with infinite or no solutions. We'll continue to solve systems of equations with 3 variables, but in this case we'll have either infinite or no solutions for the answer. First equation is 4a minus 2b plus 8c equals 30. Second equation is a plus 2b minus 7c equals negative 12. And last equation is 2a minus b plus 4c equals 15. Again, to solve these equations, you want to eliminate one variable first. Looking at the equations, the first and second equations, the b's have the same coefficients. So if we take the first equation and the second equation and add those together, the b's will cancel out. 4a plus a would be 5a. Negative 2b plus 2b would cancel. 8c plus a negative 7c would be 1c or c. And 30 plus a negative 12 would be 18. Once you combine two of the equations to cancel out a variable, in this case b, you want to use the other equation, which is the third equation we have not used, and cancel out that same variable. For example, if we take the third equation, we can multiply by 2. That way we'll have negative 2b, and then we can combine it with either equation to cancel out the b's. So continuing on, 2a times 2 would be 4a. 2 times a negative b would be negative 2b. And 2 times 4c would be 8c. 2 times 15 would be 30. From here we can use either the first or second equation. If we copy down the first equation, 4a minus 2b plus 8c equals 30. The first equation is exactly the same as the equation that we multiplied by 2 by. To combine these, we can subtract, because again, negative 2b minus a negative 2b would cancel. But in this case, the a's also cancel, the b's cancel, the c's cancel, and the 30s cancel when you subtract them. So we'll be left with 0 equals 0, And if you remember from previous sections, this would be infinite solutions.